For I know StatCrunch, it can help you with everything, but which
Yeah.
like where do I go for this type of equation?
Okay, let's see. The waiting times between a subway departure schedule and the arrival of passengers are uniformly distributed between 0 and 7 minutes. Go to stat and then go to calculator
Is it is it
and uniform.
custom?
Find the probability.
Yeah.
Randomly selected passenger has a waiting time greater than 2.25.
Standard. So the upper limit will be zero still. Upper lower and then the upper will be seven. And we need greater than 2.5.
Look at what you wrote before you, yes, thank you. Okay, and you can see the picture. Did you see the difference when you changed the sign where the picture, what the
Yeah.
picture looked like? Okay. Three.
So then OpenStat Crunch. I know confidence interval is the upper and lower limits.
I don't think we have data to put in there.
Oh, that is true. Hmm.
Can I get control of your screen so I can kind of look
Yeah.
at the calculators? So we don't have, so this is going to be a T-stat. And it's going to be, we'll just do it one sample at a time with data. And we'll do males. And we want to do confidence interval of 90%. And let's see what we get. I don't think there's anything else, but let's compute. All right.
For
So
male, that is correct. But why
okay.
is it a T-stat?
I have this chart, and I think this will be very helpful. It's the way you decide whether you're choosing between Z and T. I know that it is hard to decide if you want to use a Z table or if you're going to use a T table. This is a flow chart that will tell. And let me make this a little bigger. Okay. We start here. Do we know the population standard deviation? If we do, we go this way. Is the population normally distributed? If it is, we use our z-score. If it's not normally distributed, we find out if n is greater than 30. If it is, we can use our z-score. If it's not, then we use that alternative that we're not going to talk about. Also, we could go the other way. We don't know the standard deviation of the population. We may only know the standard deviation of the sample. We go here. Is the population normally distributed? Yes. We use our t-distribution. If we say no, then we go this way. Well, is n greater than 30? If it is, we go back and use our t-distribution. If it's not, we use another method. How do
After
you access the review quiz? You mean, how do
like do I
you view the quiz?
It's gonna be in the top three grade books.
am I allowed to do the quiz over again or no?
No,
No,
Okay,
but
that
you
I
can
thought that's what I was
review it.
able to.
you
You
click the
can click
review.
on review and then you can see what you got right, what you got wrong.
I don't know how to find this.
Assume that the thermometer normally distributed with a mean of and a standard deviation of 1. Okay. Thermometer is randomly selected and tested. Draw a sketch and find the temperature reading corresponding to P94, the 94th percentile. So 94th percentile means 0.94. What you have wrong here is that where you have 0.94, that's where the Z number would go. Where you have the other
So
number, where so the probability always goes on the right. And if you slow down for 1 second, you can, okay, move your mouse off of that spot. Okay, now just hover over the one on the right. Just hover and it'll tell you. See? Probability. Hover over the one on the left.
mm, oh
So that'll help. This is a probability.
oh thank you so much, and that's all I needed.
And then we would do the same thing for women. So compare the results. I'm looking at my stuff, and if it's just a calculator, if it's just the calculator, and I look through them, notice I have a normal calculator and a T calculator. Neither one is what I need because that's just going to tell me either the probability or the Z score or the T score, right?
Mm-hmm.
So that's not of any help. Then I look, and then and it's not summary stats. It's not. It's T stats, and we have two samples. We're just doing one at a time,
Yeah.
and we have data. So that's how I knew which one to go to. And then here's my confidence interval.
What the difference between the T calculator and T stats was?
So the T calculator really is just like the T table, like a Z table or a T table. Like
Okay.
pull one up, you'll see. That's all it is this goes along with if you had a T table, you can look it up on a piece of paper, right? If you had a table. But why do that when you have the calculator?
Question 11.
Okay. A boat capsized and sank in a lake. Well, that's a nice problem. Based on an assumption of a mean weight of 149, after the boat sank, the assumed mean weight for similar boats was changed from 149 to 173 pounds.
I want to say normal because it does say it's normally distributed.
It is normally distributed, but we don't have. Let me think. Oh, we do. Actually, that's the one we need. That's what we need. Normal. There's the mean. We
Mean
have the
is
mean, and we have the standard deviation. And
what was standard deviation over? It's the square root of
yeah,
n.
it's this.
It's already giving you the standard deviation for part A. Part B, you
Yeah,
got to figure out the standard
it's some
deviation.
weird. It's a part of the formulas we learned. I don't remember what it's,
Yes.
but it's
Yes.
rho over the square root of n.
Yes.
Yeah, it's the
That's what it
standard
is.
deviation divided by the square root of the new number, which would be the,
Yes.
so it'd be the,
Oh.
in your case, would be 35.8 divided by the square root of 15.
No, 70. We're still talking about 70
No, it's about
people.
for part B.
I'm still working on A.
Okay, maybe that's it. Maybe, I mean, the square root of that.
Then that gives us 1.
So you have to use the formula that says that the new standard deviation is equal to the standard deviation divided by the square root of n. And here n is 70, square root of 70.
Yeah.
Yeah, this is S.
Yeah, so that's a, that's a standard deviation. So that one.
I'm trying to figure out part B right now because I totally guessed. I just skipped the question. Yeah, I'm trying to figure out what to do with the pounds.
Because that's the load limit. It's not how much was on the boat. So I'm not sure that it means anything to us right now. Oh, we need to change the standard deviation. We want 35 point. I guess we have to use A, information from A, because that's the only place that the standard deviation shows up. I'm sorry, Dylan. I think you have to go back to 181.6 because
Yeah,
that's
use the new square root of the 15 for him and the square root of 14 for me.
yeah. But you have to go back to this 181.6
181.
because that's the one they're giving you the standard deviation with.
173.
Yeah,
Yes.
yeah, that's it.
And then let's see, because so the answer is D because the probability for part B is greater than 0.05.
I mean, it's a
Or-
pretty big probability. That's 82% probability that it's the weight is over what it should be. Right?
Yeah.
That's
Mhm.
that's pretty big. I mean, I wouldn't get on a boat if they said that. I wouldn't get on a boat if they said I had a 50-50 chance, let alone a 20-80, right?
Yeah, so that obviously rules out A, and then
I can't see anything below A, honestly. Okay,
that
there we go.
obviously rules out A, and then this
1.6.
rating is about 10, so it's obviously not B because that's like a minimal difference where you don't even really know.
Well, I mean, it does, 181.6 is greater than 173. Oh, that's not the reason though. Yeah. It's not, the reason is not because of that. Because it depends on the standard deviation, that would make the difference about whether or not, what the Z numbers were, or what the critical points were. Right?
Mm-hmm.
Does that make sense what I just said?
Yeah.
Okay, because it's not because of those numbers. Because there's a high probability of overloading. The new ratings appear to be safe. No, it doesn't appear to be safe, right? There's an 82% chance that we're overweight.
Yeah.
There's a high probability of overloading. The new ratings do not appear to be safe when the boat is loaded with 15 passengers. That's the truth. Because 82% of the time we're going to overload the boat,
Mm-hmm.
right? Yeah.
Yep, that's what it was. I forgot to divide the part A standard deviation by the new 3.74 square root.
I'm trying to figure out the reasoning what certain circumstances we use the S is equal to sigma over square root of n.
You have a population standard deviation, but you don't have a sample standard deviation. Does that make sense? Like, go
Yeah.
back to part A of the question. So here it says, assume the weights of people are normally distributed. If they're normally distributed, and this is their mean and their standard deviation, that's of the population.
Mm-hmm.
That's in general.
So then the population in this case would be the 70 passengers, but the sample of the people on the boat are not given.
I guess the best way I can just say it is that if you have the standard deviation for the population, which is everyone, and I want to find the standard deviation for a sample, I have to divide that population standard deviation by the square root of the number of people in the sample. And why that works, I don't know. That would probably be a calculus question.
Ready to move on to 13 if you guys are good there.
Okay, I'm ready.
So the first part I got right, the critical value, but once I got there, I could not get the margin of error.
Well, it doesn't really matter. I mean,
Either
we
was
can
fine.
use his because he got it right.
Yeah,
So it's good. His is good to use.
or if
Because
he remembers what
you're
he
gonna have to
did.
use yours, and that way I'm already connected. I can already use his. I can already touch his screen, and I'm sure it's a T stat because we don't have population anything, and it's one sample, and it is with summary, and we do know the sample mean. It is 0.8240. Is that a 9 or an 8? 8. Sample standard deviation 0.00572. Sample size 36. Okay, and we want to use a confidence level of 95%. This is not going to give me my T value though. Oh, here. You didn't have to, it's right there. So there's the critical T. You can use the same calculator. There's the critical T. The margin of error, so you have this, you have your normal curve, and you have your lower limit and your upper limit. Okay, so you're in between here, right?
Mhm.
That's the middle, and the margin of error is the distance between here and here, or the distance between here, and here, because they're the same. So all you have to do basically is say 0.826, sorry, 2601537 minus 0.82408, or the other way around. It doesn't matter. They're the same. And that should be this number. Subtract this number minus this number. It'll be fine. And the middle here is 0.82408. Then the margin of error is it's either plus or minus some value. And it's you either add that number or subtract that number. That's the biggest it's going to be. I think there's some good things on here. I think there's a lot of not good.
Let me look at my example real quick and do the math real quick.
Okay. Did that make sense?
Yeah, no, yeah, it makes sense. I got it. Thank you.
Okay, yeah, no worries.
Number 15.
Assume that all grade point averages are to be standardized on a scale between 0 and 4. How many grade point averages must be obtained so that this one we have to use close stat. I still think it's T-stat and one sample. This one is it, I think it's width. Yeah, this is okay. Okay, this is it. So you have to do width on this one. That's one I got right.
Yeah,
Let
hold on a
Let
second.
me find it again. I think it was width. Let me just do it again. Stat, T-stat, one sample, width. We have a confidence interval of 98%. Okay. We have a width of, so the range rule of thumb is 1. That means the standard deviation is 1. Okay, that's good. That's there. The width is within 0.015. It's double that. It's actually 0.03. And then compute. Yes. Would they have taken? Yeah, they would have taken mine. So we were in the tolerance level. The reason I double it is because it's plus or minus. So
Yeah,
it's,
gotcha.
yeah.
And that was probably what I messed up. That's one sample width and then double the decimal to get the correct sample size.
Yeah, so when you're looking for sample size,
Yeah.
that's what you want to do. So
Mhm.
that's the key words, sample size.
Yeah, that's another good one. You want to roll it?
Yeah.
All right.
Okay, I'm just going to stay out of it. You guys work it out.
Let's see. Maximum capacity.
All right. So you need a square root of 29 to solve it. For the
N is equal to 29. And the mean weight is 152.
I don't think you have the right calculator, by the way.
Yeah, no, I was doing this was for a question 7.
Okay.
so square root of 29 is 5.385. And then we have
36
35,
pounds.
36. Okay, so 36 divided by the 5.385.
Really want to say it would be in normal, but N is less than 30.
So do we know the standard deviation?
We do know the standard deviation.
Now this one's opposite. So that one you use the standard normal calculator, but that one you actually use the standard deviation of 36. Whereas the other ones we had to get the square root for whatever reason.
Wayne, I think this one gives us sample mean, but not population mean.
That's probably why then.
If it gives a sample mean, then it'll be different.
Yep. So
Hold on a
that's why
second.
I got it wrong on the other one, 'cause I think.
T calculator for part B because obviously
Oh, you use the T calculator for most everything.
for part B, but I'm trying to figure out how to get the first one. Is it
All right, Dylan, I'm gonna talk you through it. Go to the standard calculator.
standard?
Normal. Normal.
Oh, okay.
All right, now your mean, put in a 181. Standard deviation, put your 36. For your P of
Then
X, put the 152. And then
And then
hit compute.
oh yeah, it is normal, you're right. Well, I was thinking it wouldn't be
But
because
right,
n is
but,
not
but
greater
write that
than
down right now, like you said, and write it down for sample population.
and for part B we go to calculators T. So why did you use normal in this case? Because normally normal it either says it is normally distributed or n has to be greater than 30.
N does have to be greater than 30, or you have to have a standard deviation or something like that.
Oh, so if we're given a standard deviation, we're allowed to use normal.
Yes.
So we do stat z stats 1 with summary. Mean is 100. Standard dev is 10. Sample size. We don't know. Oh wait, no. It's
It's a T stat.
yeah, it's a T stat. With that's the one I meant to click.
Yes.
This would be 6. Standard dev is 10. Does it say what our confidence interval is? No, 99,
99.
78.
Look and see what the click on the 74.
Okay.
I don't know where to go.
Okay, the water taxi carries passengers from
I would personally just do 3750 divided by 25, and that should give you the mean weight.
Are you serious?
3750 divided by 25 will give you the mean weight.
I do not know why.
So when you find the mean, what do you do?
Isn't it just the average of all of them?
Yes, how do you find the average? You add up all the numbers, right?
Mm-hmm.
Then you divide by the number of numbers. Let's just say it like that. Agreed?
Mm-hmm.
And this would be equal to the mean. So if we add up all the values, aren't we going to get 3750?
Correct.
And then how many things are we going to add up? We're adding up, or is it 25 passengers? Yeah, we're adding up 25 passengers. So you would just divide this by 25. That would give you the mean because that's what that equals.
And
Does that make
for
sense
the
to
next,
you,
yeah,
Asher?
no, it makes complete sense. Yeah,
Can you open the normal calculator?
the normal one, this one.
Yeah. So then let's see.
Do you know why we open the normal calculator?
Because it's a normal distribution, like it says above, normally distributed with a mean.
Okay, and we
And
have the mean and we have the standard deviation.
so if
I'm sorry,
let's see
if
if
we
I
have
can.
both of those, we should have the information to get the rest.
So then we have a standard deviation of 45, but then is it?
But wait. So this is the one where you have to take the standard deviation and divide it by the square root of the
So that would
number.
be 9.
So what do we do? What are we putting here under the P of X part?
I want to say
Would that be the 150?
The 150.
Where would you put 150? Go ahead.
Well,
Where
it
you?
can't be here because this has to be between 0 and 1. So it would
Good.
have to go here.
Good.
But would
Good.
it
And then
be
what about the sign? Read what the question asks.
the direction? If the water taxi is filled, what is the probability that they're mean? So it has to be this way for the.
Right, because it's exceeding,
Mm-hmm. Thank
right?
you. So then I have original mean. So
Good. Rounds to 1.
and then okay.
Oh, I didn't expect part C. Let's see.
See, if the weight assumptions were revised so that the new capacity became 20 passengers and the water is filled with 20 randomly selected passengers, and the new load, so I have to find a new thing to go here. I have to change this to 187.5.
That's not what it says, though. Wait.
No, it's not at all. I'm so sorry.
Okay. You really have to read these and not just
Yeah.
hope that it is what you want it to be.
So no, 187 is supposed to be here.
So here's the thing. I haven't even had a chance to really read what this all says and understand it. And y'all have
Mhm.
numbers everywhere.
Think
You notice that?
Yeah.
Like everybody's just trying to figure out what numbers to put where instead of trying to figure out what this is saying. So if the weight assumptions were revised so that the new capacity became 20 passengers and the water taxi is filled with 20 randomly selected passengers, what is the probability that their mean weight exceeds 187.5 pounds? So we want to know when it exceeds 187.5, but because it assume that the weights of passengers are normally distributed with a mean, there's a mean of 195.
45 over, I have a calculator next to me. Then the square root of 20. I cannot do that in my head. That's a weird number.
No, you cannot do that in your head.
It's
Who read 5?
it's 10.062. 3. I'll
Okay,
do 4 because that's what it asked us to go to.
that's fine. No, that's fine. I think that's good. And I think that is what it's asking.
And then I think this would give you the right answer now.
0.7718.
No.
Oh yeah, thank you.
I don't have, doesn't it say 197?
Yeah, but it's
Well,
plus
the tolerance was right, but be careful.
How did I get that right? What? I just realized I
Because
put
it
that in
has a
completely wrong.
tolerance level. Hit OK. Hit OK. And then just click on that 0.771. See if it does
It
it.
won't let me.
If you get it wrong, it lets you. It has a tolerance. Like it depends on where you get your information from. If you get it from StatCrunch, you're gonna get different numbers than if you get it from a table, because it's gonna be more correct.
This
I don't know how else to explain it. So you got lucky that it was within the tolerance level.
That's very
That's
nice
all.
of them.
Yes, but be careful because it could not
I
be.
will, yeah.
Okay.
So since the probability of overloading it's over 50%,
Yes,
the new capacity does not appear to be safe.
I agree.